According to the National Electrical Code, specifically NEC 225.32C2, a group metering location must have a main disconnect if the number of meters or tenant breakers is more than 6. NEC 230.90A3 dictates that the service disconnecting means for a group metering location must be located at the point of entry of the service conductors into the building. It's important to clarify the NEC definition of the point of service. The NEC does not define the point of service as originating after each meter. The NEC defines the point of service as the point of entry of the service conductors into the building. This means that the disconnecting means applies to the feeder from the transformer to the main terminal box of the group metering. Given these requirements, a group metering location with more than 6 meters or tenant breakers necessitates a main disconnecting means at the point of entry of the service conductors into the building. While local practices might sometimes deviate from these standards, adhering to the NEC ensures safety and proper electrical installation. Installing a main disconnect offers added safety and versatility by enabling the isolation of the entire group metering location when needed. When preparing project quotes, it is crucial to align with NEC requirements, even if it leads to a higher bid compared to competitors who might not be following the code. This commitment to compliance ensures a safer and more reliable electrical system. Understanding the specific requirements of the NEC is essential for electrical installations, particularly concerning group metering and disconnects. The code provides clear guidelines on when a main disconnect is necessary, emphasizing safety and proper functionality. Let's delve deeper into the specific sections of the NEC that govern group metering and disconnect requirements. Firstly, NEC 225.32C2 explicitly states that a group metering location must have a main disconnect if the number of meters or tenant breakers exceeds 6. This rule is designed to provide a means of disconnecting all power to the group metering installation in case of an emergency or for maintenance purposes. Secondly, NEC 230.90A3 specifies the location of the service disconnecting means. It mandates that the disconnect must be located at the point of entry of the service conductors into the building. This ensures that the disconnecting means is readily accessible and can quickly isolate the entire electrical system from the utility supply. It is crucial to understand that the NEC defines the point of service as the point of entry of the service conductors into the building, not after each meter. This distinction is important because it clarifies that the disconnecting means applies to the feeder from the transformer to the main terminal box of the group metering. The authority having jurisdiction's interpretation that the point of service originates after each meter is not in accordance with the NEC definition. Consequently, a group metering location with more than 6 meters or tenant breakers requires a main disconnecting means at the point of entry of the service conductors into the building, irrespective of local interpretations. While some areas may have a common practice of allowing group metering without a main disconnect, this does not align with the NEC. It is essential to prioritize code compliance to ensure the safety and reliability of the electrical system. Installing a main disconnect offers several benefits. 1. It provides a means of isolating the entire group metering location in case of an emergency or for maintenance. 2. It enhances safety by allowing for the quick disconnection of power to the entire installation. 3. It ensures compliance with the NEC, which is crucial for legal and insurance purposes. When preparing project quotes, it is imperative to adhere to the NEC requirements, even if it results in a higher bid. Cutting corners to reduce costs can compromise safety and lead to potential liabilities in the future. In conclusion, understanding and adhering to the NEC requirements for group metering disconnects is essential for electrical installations. The code provides clear guidelines on when a main disconnect is necessary, emphasizing safety, reliability, and code compliance. Always prioritize code compliance to ensure the safety and proper functioning of electrical systems. Let's further clarify some practical considerations and potential challenges that may arise when implementing these NEC requirements in real-world scenarios. One common challenge is the cost associated with installing a main disconnect. Some contractors may be tempted to omit the disconnect to reduce costs and offer a more competitive bid. However, this approach can compromise safety and lead to potential liabilities. It is crucial to educate clients about the importance of code compliance and the benefits of installing a main disconnect, even if it adds to the overall cost of the project. Another challenge is the interpretation of the NEC by local authorities. As seen in the initial scenario, some authorities may have a different understanding of the code than what is explicitly stated. In such cases, it is important to engage in open communication with the authority having jurisdiction to clarify any discrepancies and ensure that the installation meets the code requirements. It may be necessary to provide documentation and evidence to support your interpretation of the code. In some cases, it may be necessary to seek guidance from a qualified electrical engineer or consultant. They can provide expert advice and assistance in interpreting the code and ensuring that the installation meets all applicable requirements. It is also important to consider the specific characteristics of the building or facility where the group metering is being installed. Factors such as the size of the building, the number of tenants, and the type of electrical loads can all influence the design and installation of the electrical system. In some cases, it may be necessary to install additional disconnects or other safety devices to ensure the safety and reliability of the system. For example, in a large multi-tenant building, it may be necessary to install individual disconnects for each tenant unit in addition to the main disconnect for the group metering location. This would allow for the isolation of individual tenant units without affecting the power supply to the other units. It is also important to consider the future needs of the building or facility. As the building grows and changes, the electrical system may need to be upgraded or modified to accommodate new loads or tenants. Installing a main disconnect with sufficient capacity can provide flexibility for future expansion and modifications. When selecting a main disconnect, it is important to choose a device that is properly rated for the voltage and current of the electrical system. The disconnect should also be listed by a recognized testing laboratory, such as Underwriters Laboratories Incorporated, to ensure that it meets safety standards. It is also important to install the disconnect in a location that is readily accessible and protected from damage. The disconnect should be clearly labeled to indicate its purpose and function. Finally, it is essential to document the installation of the main disconnect and other electrical equipment. This documentation should include drawings, specifications, and test reports. This documentation can be valuable for future maintenance, troubleshooting, and modifications. In summary, implementing the NEC requirements for group metering disconnects can present some practical challenges. However, by understanding the code requirements, engaging in open communication with local authorities, and considering the specific characteristics of the building or facility, it is possible to ensure that the installation meets all applicable standards and provides a safe and reliable electrical system. Remember to prioritize code compliance and to consult with qualified professionals when necessary. Let's explore some common misconceptions and frequently asked questions related to group metering disconnect. One common misconception is that a main disconnect is only required for residential buildings. However, the NEC requirements for group metering disconnects apply to all types of buildings, including residential, commercial, and industrial. Another misconception is that the authority having jurisdiction has the final say in interpreting the NEC. While the authority having jurisdiction has the authority to enforce the code, their interpretation must be consistent with the intent and meaning of the code. If there is a disagreement, it may be necessary to appeal the authority having jurisdiction's decision to a higher authority. A frequently asked question is what to do if the existing electrical system does not comply with the current NEC requirements. In such cases, it may be necessary to upgrade or modify the system to bring it into compliance. This can involve replacing outdated equipment, adding new disconnects, or rerouting wiring. The extent of the upgrade will depend on the specific deficiencies of the existing system. Another frequently asked question is whether it is possible to obtain a variance from the NEC requirements. A variance is an exception to the code that is granted by the authority having jurisdiction. Variances are typically granted only in cases where compliance with the code would be impractical or would impose an undue hardship. To obtain a variance, it is necessary to submit a written request to the authority having jurisdiction, explaining the reasons why compliance with the code is not feasible. The authority having jurisdiction will review the request and make a decision based on the specific circumstances. It is important to note that variances are not always granted, and it is always best to comply with the code whenever possible. Another frequently asked question is whether it is permissible to use a circuit breaker as the main disconnect. Yes, a circuit breaker can be used as the main disconnect provided that it meets the requirements of the NEC. The circuit breaker must be properly rated for the voltage and current of the electrical system, and it must be readily accessible and clearly labeled. It is also important to ensure that the circuit breaker is installed in a suitable enclosure and is protected from damage. Another frequently asked question is whether it is necessary to obtain a permit before installing a main disconnect. In most jurisdictions, a permit is required before performing any electrical work, including the installation of a main disconnect. The permit process ensures that the work is performed in accordance with the NEC and that it is inspected by a qualified electrical inspector. To obtain a permit, it is necessary to submit an application to the local building department or electrical inspection agency. The application should include drawings, specifications, and other relevant information about the proposed work. In summary, understanding common misconceptions and frequently asked questions about group metering disconnects can help to ensure that electrical installations are performed safely and in accordance with the NEC. Always consult with qualified professionals and obtain the necessary permits before performing any electrical work. By addressing these questions, professionals can ensure installations meet code requirements. In addition to the NEC requirements, there may be other applicable codes and standards that must be considered when designing and installing group metering disconnects. These may include local building codes, fire codes, and utility company requirements. It is important to be familiar with all applicable codes and standards to ensure that the installation is safe and compliant. Local building codes may specify additional requirements for electrical installations, such as the type of wiring methods that are permitted, the location of electrical equipment, and the grounding and bonding requirements. Fire codes may specify requirements for fire-resistant construction, fire alarm systems, and emergency lighting. Utility company requirements may specify requirements for the connection of the electrical system to the utility grid, such as the size and type of service conductors, the metering equipment, and the protective devices. It is also important to consider the specific characteristics of the electrical loads that will be served by the group metering system. This includes the type of loads, the size of the loads, and the voltage and current requirements. The electrical system must be designed to accommodate these loads safely and efficiently. For example, if the group metering system will serve a large number of motors, it may be necessary to provide additional overcurrent protection to prevent nuisance tripping. If the system will serve sensitive electronic equipment, it may be necessary to provide surge protection to protect the equipment from voltage transients. It is also important to consider the environmental conditions in which the electrical equipment will be installed. This includes the temperature, humidity, and exposure to corrosive substances. The electrical equipment must be suitable for the environmental conditions to ensure that it will operate reliably and safely. For example, if the equipment will be installed in a damp location, it must be rated for wet locations. If the equipment will be exposed to corrosive substances, it must be made of corrosion-resistant materials. In addition to the technical requirements, it is also important to consider the aesthetic aspects of the electrical installation. The electrical equipment should be installed in a neat and workmanlike manner, and it should be concealed or protected from view whenever possible. The electrical installation should also be designed to be user-friendly and easy to maintain. In summary, designing and installing group metering disconnects requires careful consideration of a variety of factors, including the NEC requirements, other applicable codes and standards, the characteristics of the electrical loads, the environmental conditions, and the aesthetic aspects of the installation. By taking all of these factors into account, it is possible to create an electrical system that is safe, reliable, efficient, and aesthetically pleasing. Always consult with qualified professionals and obtain the necessary permits before performing any electrical work.